today's tutorial,
we'll continue where we left off previously. So let's continue. So I'm gonna scroll up. Um, so let's see. So we left it. We last did 2.1. So we're gonna continue from 2.2, right? So suppose that the above class has an enforced range member function that ensures a given value is in a specified range. Provide code that declares a simple two-class hierarchy consisting of a base exception type, and the specific exception type for an error that would occur if a provided value was not in range, right? So they just want to see you what is it? See you demonstrate exception handling. So create those classes, right? That's all they want to see there. So the way I'm gonna do it is the way you should also do it. So let me close Postman. So 2.2, right? 2.2. So we need to create. So we're dealing with a range, right? So we're dealing with ranges here. So we have it might be in range or it might not be in range. So in exception handling, right? All exceptions, they derive from this one base class, which is called the exception class. So that's the first thing that you need to put there, right? And it's going to be just an empty class. So I can put it in one line like this. There's no need for me to do something like this, like we've been doing so far, because it's empty either way. So there's no point in doing that. But some people will actually see it a bit clearer if I do it this way. So let me do it this way. So let me cut this off. So let me do it this way so that some people can envision it properly, because if I do it that way, some people tend not to see it. So this will be like the founding ancestor, right? This will be like the first person within that lineage, right? Or within that family tree. So that's exception. Then we can have some subtypes, right? Basically, classes that inherit from this base class. So since we are dealing with what we call a range issue, right? So we are dealing with range issues, but we want to deal with the range using exception handling, right? Because here they say that provide code which declares a simple two-class hierarchy consisting of a base exception type and the specific exception type. So they want you to come up with the base exception type. By base, they just mean the exception type, exception class, which is just exception. But then they also want you to provide a specific exception type. So what type of exception is that? So we are dealing with a range issue. So this will be a range exception, which inherits from, and then this is going to be public inheritance, which inherits from the exception class. So that's all you had to do here. But you could also take it a step further and say, remember, there's two types of range exceptions. There's the minimum range and there's the max range. So you could have two extra classes, but they say they only need two. One, which will be just the generic base class. Then the second class will be a specific exception, which is this one. You see, it's a specific exception. It's a range exception. So I'm going to leave it this way. And then 2.3, let's go to 2.3. So 2.3, write code to protect the following using exception handling. Assume that Assuming that the class has been updated to raise exception types defined in the previous sub question. So this is, you see that we are passing parameters here, or values, right? Or we are passing arguments. right? So when you call the function and you pass in information, they are now called arguments. So we're passing these arguments, right? And these arguments may not be in range. Hence, they told you in 2.2 to create that class hierarchy. So if you get that class hierarchy, if you don't get it wrong, you also get it wrong here. So be very careful. Maybe you might get 1 mark at most for just having the exception, or 1.5, which is half the marks. But make sure you do the right thing in question 2.2. So they said we should rewrite this code in such a way that it takes into account exception handling. So that means this constructor here, you see this object here, object field that we've created, it might throw the constructor, right? Remember, we're calling the parameterized constructor here. So that means the values might not be in the range. So therefore, I need to put it within a try catch. So remember, with the exception handling, the simple way to master exception handling is that you try something, right? And then then this part, right, you are trying something. Hence, we call this the try block. Within this curly braces of the try block, we are trying something. But then this something might throw an exception. Listen to the terminology that I'm using. It might throw an exception. Obviously, if you throw something, someone needs to catch it. So someone needs to catch it. So for example, if you have a dog and then you have a tennis ball, and then you throw the tennis ball, and then you tell your dog, um, Bobby, go fetch, right? So that dog will run and go fetch the ball. But let's say, for example, the dog is like it's already there at that distance, and then you throw the ball towards it, and then the dog jumps and then it catches the ball. Or you throw that thing, I don't know, that thing that sort of looks like a plate, and then you tell the dog to catch, right? In order for it to catch, you must first what? Throw. So you throw it and then your dog catches it. So our code, right? They said assume. If you look at the question, right? Assume that the class has been updated to raise an exception. To raise an exception, it's also the same as saying throw exception. So it's one and the same thing. They're used interchangeably. In Python, you actually use the keyword raise, but then throw and raise they're used interchangeably. They mean the exact same thing. So throw or raise, it means to just throw that thing, right? So imagine you throw something to your dog and then your dog catches it. So since we have try, this code that we're going to put in here, let me put the code. So there's the code here, right? There's the code. So the code that we're putting here, it has arguments, right? Meaning that these values might not be in range. For example, they did it on purpose here. They now put -1 to show you that some users can pass in wrong values. So that means they will throw an exception. We need to catch that exception. What type of exception should be caught? It's the range exception because they might be out of range. Remember, we defined it here. So that's what I said. If you don't declare to do 2.2 properly, you're going to have issues. So this will be a range exception. I'm going to call it EX. And then I need to output an error, right? So standard error. And then I'm going to say out of range. And then I'm going to put an end of line character. So you catch the exception. And then you could also just catch the general exception. So remember the way exception handling works, right? Is you try something and then you have multiple catch blocks. So the multiple catch blocks, right? The way they operate, or the way they work, is you always start with the most, with actually you start at the bottom and then you go up, you climb upwards in the inheritance hierarchy. What do I mean by that? So let me show you. So draw.io. Remember, with inheritance, the first class is like at the top of the inheritance hierarchy. and then the subclasses are at the bottom. So that's why I say you start at the bottom, right? You start at the child classes, then you work your way upwards. So I'm gonna create a new diagram, and then this will be UML. Okay, this will be inheritance. I mean, so inheritance, and then create. So like I said, you're gonna have your exception class here. So I just want you to really understand, because they might ask you a bit questions that are a bit difficult. They expect you to understand. So we have this, and then we have this, and then I'm going to have the other subclass, right? Which is the range exception, right? So far, so good. So this is the range exception, and then it inherits from this exception class, right? Remember, we have inheritance. If you remember our 2.2, you see we have public inheritance. So it does indeed inherit, because range exception is a exception, or it's is a type of exception, right? So we could have this, right? So the way it works when you creating your catch, when you're adding the catch blocks, right? By catch block, it's, you see where in your code where you use the catch keyword, this is what we call a catch block, because it's a block of code that catches that exception that was thrown, right? Remember the terminology. So we have this range exception. So when you create putting your catch blocks, you always try with you start with the bottom of the inheritance hierarchy. So you start with the most specific exception. Because if you start with the exception, what's going to happen? It'll catch all exceptions, and we won't actually know which exception was thrown, which becomes a problem. So that's why we always start with the range exception. So there's the range exception. I could demonstrate, right? But then I don't have time to be creating a whole CPP project. But I could demonstrate how you can, what would happen if you start with with the base class instead of the child class. But then just remember, that's a problem. You shouldn't do that. You always start with the range exception, and then you work your way up the inheritance hierarchy. So in this simple example, I have only one base base class, which is exception. So after this range exception, I'm gonna put in the catch block to catch just any exception, because remember, it's this exception class is generic, right? That means it catches any generic error. So we don't actually know what type of exception is that, but then we know something went wrong. So I'll just say something went wrong. Like I said, it's not specific. We don't really know exactly what type of exception. It's just an exception. So that's pretty much how you should answer 2.3. So you put in that code that might throw an exception, of which they gave you in the question paper. They said this is the 2 lines. So they go into the try block. So we try doing this. If it happens to throw an exception, we need to catch that exception. So that's the terminology for it. So this is, then we go to 2.4. So let's go to 2.4. Consider the following node-based data structure representing the neighbors of a B cell for the remaining sub-questions, right? Um, okay, they're giving you the node. Okay, so this is a doubly linked list. Yeah, this is insane. So this is a doubly linked list. So you need to actually, like I said, this question paper was not easy at all. Like, I don't want to lie to you guys. If you didn't study or prepare well, you're going to get chopped here. So we see that we have an arrow pointing to the first node, right? And then this node, it points to N2. But then N2 also points to this node, right? And then N2 points to the next, but then N3 points to the previous. So in order for you to understand what's going on here, they are pointing at each other. It's like that's the Spider-Man meme, right? So let me say Spider-Man linked list example. So it's like the Spider-Man meme, right? You see, they're pointing at each other. Yeah, this is the specific one. So you see, they are pointing it at each other. This one is pointing to this, but then this one is also pointing to that. So it's like they are pointing at each other. So the way I want you to view this, I'm gonna use people, right? Imagine people in a queue. I think that okay, not the text. Okay, so I can't can't I enlarge this? Okay, it's fine. I'll just zoom in. So imagine this is person number one. Then this is the next person in the queue, and then let's just make it simple. Let's just say it's three people in the queue. So this person has an address, right, of the next person, of the person in front of them. But then also this person has the address of the person behind them. And then here, this person has the address of the person in front of them. And then that person also has an address of the person behind him, right? So this is what we would call a doubly linked list. You see, it's linked twice, like in a double manner. There's two arrows, so doubly linked. Obviously, this one is not pointing to anything, so this would point to null. And then this would also just not point to anything. But the way I like to, or the way you should, it's advisable you do linked list this way. So you create a node, right? Imagine, remember these people that we have here. The people that we have here, they're representing nodes, right? So this will be node one, node, okay, this will be node one, node two, okay, node one, node two, node three. So what we can do, right? Because sometimes our linked list can become long, right? At some point it's going to be long. So imagine you have 15 million records. How would you know which one is the first node and which one is the last node? So what, in order to handle that issue, or that error, or to avoid that error, we create two nodes, right? We create one node which we create one node which points to the first node, and then we create another node which points to the end, right? So this would be these two nodes here. They'll help us to keep track of where does the node linked list begin and where does the linked list end. They're typically called head and tail. Imagine a horse, right? This would be its head, which is where the horse starts, right? Hence it's called a head. And then this will be the horse's tail, which is where the the way the horse ends, it ends at its tail. So this is typically the way you go about it. Obviously, this node should point to null pointer, which is basically zero, right? But then we say that's null pointer, which is just backslash zero. So this will now point to null pointer. So yeah, so that's pretty much how we go about doing it. So the tricky part is when you're inserting, that's the tricky part. So when you're inserting, you need to find where to insert. And remember so how would we define this record structure? That's the question. So let's take one node. Let's just take this middle one. So let's look at this middle node. So this middle node, there it is. It is an address of its next, meaning the next person in the queue. But then it also keeps track of the previous person. And remember, by next and previous, we are talking about addresses. So those would be pointers. And it also keeps track of its own value. Let's say this is 10, or let's say the value is the amount they want to deposit, right? So that would be 100 Rand. And then this person wants to deposit 1.5. And then this person wants to deposit 350, right? So this person got their grant and they want to deposit into their account. So you see that this each node, right? It has three things. We have the value of that node, and then we have the address that points to the next node, and then we have an address that points to the previous node. So we have three. So that's how we're going to structure the data structure, the structure, the record structure, or the data structure. That's another term for it. So provide code for a templated, so it needs to be generic, meaning it can accommodate any data type. Generic structure compatible with the depicted data structure, right? And remember this diagram, this X here represents null. So that's there. Okay, for the last node, you don't necessarily have to keep track of the tail, but they sometimes so that's another way. I want you to know all the approaches. That's another way. But then the head is very important. Why is it important? Because in this example, you'd be like, well, node N1 is the first one, so I know that's the first node. What if you kept inserting and you kept inserting in the front? If you insert in the front, that means that's an N1 will no longer be the first node. So how will you find the first node? So hence we need to have a node that points to the head. So that's very important. So remember we talked about the data structure, right? So for a node structure, so they say the node structure. So since they say the node structure, I'm going to call it node, the record structure. So 2.4, it's time for me to create they said templated. So I'm going to make it a template, generic, right? So template type name T, right? You can do that. But then let me actually put it in a program. I like to use VS Code for linked list because VS Code is short and it's just straightforward, right? So I'm going to create a I'm going to create a folder, right? So let me open my prompt and then I want to open the terminal. Okay, no, this is not open terminal. Okay, it's not, doesn't want. So let me just open it this way. So I can use pwd to open my toggle size to content. Okay, so I can print my working directory to see where I currently am, right? Working directory, remember directory is a folder. And then I can use ls to list all the folders that are currently in here. So I want to save this and let me see desktop. So I'm going to use cd to change to the desktop directory. And then I'm going to clear and then ls. As you can see, this is my desktop. So now I'm in my desktop. I can create a folder. So I'm going to say mkdir, which stands for make directory or make a folder. So this folder will be called linked list question 2.4, right? Or two. Okay, let's just say linked list question and then enter and then ls. So there's the folder, it now exists. And then now since the folder exists, I'm gonna say clear and then I'm gonna open the folder now because that's how VS Code works. It works with folders. You need to have the folder there. You could have done it the easier way. I just did it this way. So let me say I trust this directory and then close. Okay, let's wait for the terminal. Okay, let me close the terminal. It's taking precious time. Okay, so as you can see, if I say ls, there's nothing in the folder. And you can also see in the Explorer that there's no folder. You could click here to say new file, or I'm gonna teach you a bit of Linux. So you can say touch command just means create a file followed by the file name. So the file name that I want to create, I'm going to call it linked.cpp, right? And then you see that it should appear this side. So there's the linked.cpp, and then double click, and then yes. So I need to install the C or C++ extension so that it can highlight when I'm typing that this is C++ code. So I'm going to close this terminal, and then I'm going to minimize that. And then I'm going to go to my settings, and then open zoom settings. Okay, so yeah, I can zoom in, so that's fine. Even the DLL question, I'll also do the same thing here. So let's wait for it to load, and then we'll answer. So for inside the CPP file, I'll put a comment specifying which question is that. Is it question 2.4 or 2.5? So that you guys know when you open the CPP file. So if you look at the bottom here at the bottom, it says C++. So now it knows which language. I told it to auto detect, which is fine. So I'm going to say hash include IO stream, right? And then I'm going to have my main function int main. I'm not going to work with any command line arguments, so I'm not going to pass anything. And then now I need to define my record structure. So I need to come here and define the record structure. So this is question 2.4, where we define the data structure, where we define the data structure or a record structure. They are used, they're used interchangeably. But then they said it's templated, meaning that it's a generic record structure. So I'm going to say template. And then this time around, I'll show you that it works. Remember when you're doing the other questions, I said you can either use type name or class. So I'm going to use the class keyword. So class T. Okay. Main is not a valid function template, blah, blah, blah. Okay, it's fine. It thinks I'm trying to make main as a template. Yeah, and then yeah, the error is gone. It thought this template is part of main, but I'm not done working. Yeah, pap, it's being too forward. So struct, I'm gonna use the struct keyword to make a record structure. As you can still see, the struct keyword comes from the structure term. So I'm gonna call it node, right? And then I don't know why VS Code doesn't put the semicolons, but it's fine. So it's a node, right? This record structure represents one node, right? And if you look at each node, it has the address to its next, an arrow that side, and then an arrow also going this side. That's why I decided to draw it my way, because if you look at that in that way, you get confused. You see the arrow, there's an arrow that goes this side, then there's an arrow that also goes behind, right? And it also has a value. So the value is going to be generic, right? So it's going to be of type T. So I'm going to come here and say T. This will be the value of the node. And then after that, I need to have the address that points to the next node and an address that points to the previous node. So that means it points to a node. Remember the terminology, it points to a node. So therefore, I'm going to use this node name, this type that I'm defining there, because it points to another node. So, and it's generic. Remember, it's templated. So I need to pass in T. So node T, pointer. Remember, it points to the next node. It's actually kind of self-explanatory. It points to the next node. So I need to create a pointer. So this will be next node, right? This will be, that'll be the address of the next node. And then node of type T, pointer. This is the address of the previous node. But you can call it prev, but I will just write it in full and say previous. So this is how you declare it in full, right? So that's how we declare it. So we now defined one node. One node is a value, and you can either point to the next or it point to the previous node. So we've answered 2.4. That's question 2.4. So we have the full 5 marks. And then now there's interesting question, right? Provide code for inserting the value N7 at the end of the list. So we need to add that node at the end of the list. But before we do that, I know this is not something that you should be doing. I just do this so that we can have output, right? That's why I'm doing that, so that we can have output. And they said it should contain the value n7. So that means n1, n2, n3, those are actually the values. So this means this is going to be a linked list of type string. But then since it's of type string and string is a class, so I need to include it before I do anything. So I'm going to include the string header file, and then I'm going to come here. I need to build so remember I need to return 0, or in some instances you can just say exit success, which is just 0. You see, it's a constant 0. There's many ways to return. So I'm just going to do it this fancy way using the macro defined inside C. You see, it says it's what successful exit status, which is just a 0. It's just a fancy way, just a cool way of going about it. So before we can actually see output, right? I need to build this whole linked list. And how do I go about building it? So remember what I said, we need a node to point to the first node, right? Which is N1. And we typically call that the head. Just like think of it as like an animal or a dog or a horse. It is the head, which is the front, and then it is the tail, which is the end. Right? So I'm gonna put in comments and say build my doubly linked list, right? I just want to build it so that we can have output. Then I will put a comment where we actually answering the question, so that we can see that it did actually insert the node. So I need to point to N1, so I need a head. So I need to create a node. Remember, we're using string, and it's part of the standard namespace. So std string pointer, and then this will be the head. It will represent the head. We don't know where the head actually points yet, because we don't know. um and for the head node, the only address that we care about is its next address. The previous doesn't really matter, because if you look at this diagram, is there a node before the first node? There's no node before the first node. So since there's no node before the first node, previous will just be empty. We can just set it to now, right? Now pointer, to say that there's nothing, previous is not pointing to anything. So I will do that. But before I do that, let's create our nodes. So how many nodes do I have? I have N1 to N6. So the way I'm going to go about doing it, I'm going to remember in C++ you can declare multiple variables of the same type in one line. So I'm going to say node, and then from standard namespace, I'm going to use the string class. Then I'm going to have, should I say N1, N2? Yeah, let's do it this way. N1, N2, N3, N4, N5, N6, N7, right? So you see that it has saved me a lot of time. I wrote it in one line. So some features in programming, you must use them to your own advantage. So now let's link, right? So we do know that the node N1 has a value of N1, or has the string of N1. But then there's multiple ways you can go about doing it. You can set the values first, or there's literally endless combinations or endless ways you can approach it. The way I'm going to do it is I'm going to set the values first, then I link afterwards. In whatever order, it doesn't matter. You can link first, then set the values. It's up to you. So I'm going to say initialize the values for each node, right? And the way I've named it, it actually makes things easier for you, because I've named it N1. So remember, it's a pointer. So I need to actually dereference first before I use the dot. I'm using the dot. Why am I using the dot? Because it's part of the struct. See the struct, I need to go within the struct and get value or get next or get previous. So I'm gonna do this. Remember, this is how you can do it. This is how we used to do it, right? And say dot, right? And then you get the value. So you dereference. By dereferencing, it means that you're going to that address, which is address N1, and then you accessing those that inform that node, right, at N1. But then this is very cumbersome. It's very untidy. So we typically use the arrow like this, which is an easier way. So I'm going to set the value to be n, I said n1, right? And it's in capital letters. You don't have to put it in capital letters, it's fine. But then I'm going to follow that convention. So this will be n2. Don't I have n2? Is applied to instead of pointer. Oh, yeah, I remember reading about this. When you the problem with this, right? Let me explain something. If you say int pointer a b, right? C++ is stupid. It only makes a as the pointer. B, it ignores it. It actually declares b as like an integer. If you see, if I go over it, you see that it's called int b. But then if I go over this one, it's int pointer. C++ does that. So in order to fix that error, you'd have to put the pointer next to every single argument like this. So you need to explicitly say these are pointers. If you want to declare them line by line, that's up to you. But then I'm declaring it this way to make things simpler for myself so that I have less code. And then N3, and then value is just N3. You see, if you name your variables properly, you don't have to think about a lot of things. And then N5 is that value N5. And then N6 is that value N6, right? See, I didn't have to think about it a lot. And then remember the head, like I said, it's just an empty node. I don't have, it shouldn't have a value. The only thing that it should store is the next, so that it points to the first node. That's its only purpose. So let's build the node, the linked list, right? So we need an arrow that points to N1. So that means the heads next needs to point to the address of N1 so that it points to N1, right? So now I'm going to link the list or link the nodes, right? That's what I'm going to do now. So heads next is going to point to N1, right? So when I do this, now it's basically this. Now the head is pointing to the first node, of which in this case we chose to be N1 because that's how we were given in the question paper. Remember, all I'm doing right now, it's not answering the question. I just want you to see the output when you test it. You can also test it in many ways. You can create questions for yourself. Try to insert maybe after N3, or try to insert at the end, or try to insert at the beginning. There's many ways you can. That's why I'm creating it, going through all this effort to do this, so that you guys can experiment. So I'm building the node first before we get to this question, so that we see the before and after, so that you see that it actually does output. It actually does insert. So we have this node N1. So N1, it points to the next node. So in this case, N1, if you look at the diagram, right, N1's next is the only one that's going to be initialized to point the next node because there's no node before N1, right? So therefore, I'm going to say N1's next points to N2, right? It points to N2. So I've drawn this arrow. When I say it points to N2, I've drawn now this arrow. But then N2's previous, it points to N1. Remember, they're doubly linked list. They're linked to each other. So it's like they're literally pointing to each other. This one points to this one, and then this one also points back. It's like, yeah, I'm gonna point back at you too. So now N2's previous, remember it's previous, right? It points to N1. If you do not do the diagram properly, you're gonna have issues, right? So let's see this, right? So what I'm going to do is I'm going to let's forget about the values. Let me put N1 here. Come on, and then N2 here. And then let me delete this. And then this now I'm gonna put it there at the end. So in this scenario, I didn't create a tail. You could have created it, but in this example, specific example, I didn't create it. So let's sort of like rewind. So this is what we have so far. All of this is what I have so far. When I said set heads next to point to N1, it literally drew an arrow like this. So this was this part. And then set N1's next to point to N2. So N1's next points to N2. But then if you look at N2's, its previous is pointing to the person behind. So therefore it's previous. You could use behind to say that this is a person behind, or front. You could do that, right? That's up to you. If writing it in that way makes sense for you. Next, you can say in front, and then previous, you can say the person behind you. So point to the person behind you, point to the person in front of you. But then either we actually in actual programming, we use they use next and previous. But if it helps you, you can do that. They wouldn't mark you wrong. Trust me, it's fine as long as it makes sense, because you said front and behind. That's simple English. People can understand. So previous, when I said N1's next to point to N2, that's what it did, which is this part over here. N1's next, it points to the address of N2. And then N2's previous, it points to N1, which is this part over here. So this is exactly the diagram that we have so far. So we are not done yet. We need to keep adding. So I'm going to add another node, which is N3, right? So this will be N3, right? That's N3. So how can I link N3 to N2? I start by setting N2's next to point to N3. So let's do that. So I need to create this arrow. N2's next points to N3. I think I should, but then I'm gonna use a lot of space now. So, but then it's fine. So this is N1's next, right? So just know this is what it means, and then this is previous, right? So the thing is, it will take time for me to build the full diagram, but just know when you have an arrow that side, I'm referring to this node's next. Look at the way the arrow is coming from N1. So it means N1's next points to this. Look at where the arrow is coming from, N2. That means N2's previous is pointing to N1. So the diagram is kind of self-explanatory, but it's fine. I think I'll build the full diagram and then export it to an image, then save it so that you guys can see it visually. So N2's next, right? We need to set that N2's, you see where the arrow is coming from, N2. So that means N2's next needs to point to N3. Like I said, if you do not draw the diagram, it'll be very hard for you to grasp this. So no, it's N2's next points to N3, right? So we have that. This is that arrow. Then now N3's previous, because you see N3 is pointing to the person behind them. So that means we are referring to the previous address. So that means N3 is previous points to N2. So N3 is previous points to N2. So N3 is previous points to N2. That's why when I do this linked list, it's rare for me to find errors, to get errors, because I'm doing it using a diagram. If you're taking chances and you're not using a diagram, you definitely have issues. Don't take those chances. Unless if you have good you have a good mind, right? You have good memory. You can picture and you have vivid memory, right? You can picture things. Some people, like for example, if they tell them to think of, they should think of an apple, they think of the word apple. Some people, they can think of it in 3D form. That's it depends on the person, but I like to do diagrams to make my life easier. So now N3 is next, right? Because it's pointing forward. That means the person in front or it's next needs to point to N4, right? So it needs to point to N4. So N3 is next needs to point to N4. And then N4, on the other hand, it points to the previous one, which is N3. So N4's previous, right? N4's previous points to N3. So N4's previous points to N3. If you fail to link properly, your code's gonna crash. And it'll be very difficult to find where you went wrong if you don't have the diagram. And if you're not doing it the way I'm doing it here, adding one node at a time. So there's another node, right? So N4's next points to this node. So I need to set N4's next to point to N5. Um, come on. N5. So N4's next needs to point to N5. So N4's next needs to point to N5. I know it's a bit long, but trust me, it'll be all worth it at the end. And then N5's previous is pointing to N4. So N5's previous, okay, so let me shift it this side a bit. So N5's previous is pointing to N4. So N5's previous, so N5's previous is pointing to N4. And then the last one, which is N6, that's the last node. You see how easy it becomes to insert. You're like, are they really serious about this or they're just joking? Because you have a diagram. That's how easy it becomes when you have a diagram. So N5's next, right? It points to N6. So N5's next. So let me add that. N5's next points to N6, right? That's this line over here. Then now N6 previous, right, points to N5. And then I need to shift it to the side a bit. And then N5, N6 previous points to N5. So N6 previous points to N5. And then there we go. We have built that linked list, doubly linked list that is on the question paper. But then we are not done because this doesn't tell, we haven't set, we did set N6 previous, but we didn't set N6 next. So we need to set N6 next. So N6 next points to null because that's the last node. points to N6. N6 next points to this because that's the last node. So it has to point to null because there's nothing after it. So I need to set that. If you don't set it, you get an error. Be very careful. It should point to null pointer. So now we have built the node, right? The linked list. So now we have built the linked list. Now we can output the linked list. So output the linked list. But then we are not done. Let me see. Oh, we are done because we did set the head, right? So there's the head. So when you traverse, right? Traverse, like I said, they use fancy English. Traverse just means go through. So when we traverse the list or we go through the list, then we always created a temporary node, right? So we create a current node because we don't want to change our nodes. We create a current node. So this is how it works. So let me show it visually. So we create a node. Let's say we create a node called current, right? Current. And then we make it point to the first node by pointing to head, because remember head stores the first node. So therefore I will point to N1. And then I output the value of N1, and then I update the address of the next node that current is pointing to. So current will now point to N2. So it now deletes that error and then now points to N2, and then it points to N3, and then it points to N4, and then it points to N5, N6, and so forth until it reaches null. So that means when I find out that it's now that's null, that's when I know that I've reached the end and I need to leave the loop. So how am I going to do that? So I'm going to say I'm going to do a while loop because I don't know how many nodes are there. You will never know how many nodes are there. You can't do a for loop. Don't ever do a for loop. So I'm going to go N1, N2, and then N3, and then I go to N4, and then I go to N6, and then I go to null. So when I reach null, I need to what? Exit. So that means while I'm not, while, and remember what I said, current next is the what we're going to use. So while current next is not equals to null, then I should keep on going into the linked list. That's what it means. So that means I'm going to create a current node. So I'm going to say node type string, right? But string isn't a standard namespace. Pointer, and then current, it points to the head, right? Not to the head per se. Let's not, yeah, don't point to the head. Point to whatever head's next is pointing to, which will always point to the first node. So that means I need to point to the head's next, right? Basically the address that's stored by head, or basically the node that head is pointing to. Some people might be like, well, what a waste of time. I know the first node is N1, so why don't I just say N1? Well, in this case it's N1, but then remember linked list, you can add at any place, at any location. It's not always going to be N1. So that's why we created a temporary a node, an empty node head, right, which only stores the first, which only allows us to point to the first node, so that we don't have to try and find out or go through our code and search for hours trying to find out what's the first node. So remember what I said, we use a while loop. So while the current, right, the current address is not equals to null, right? That's how you go about doing it. Because we're going to traverse, I'm going to go to N1 and then eventually I get to null. So as long as I'm not equal to null, then that means there's a node, right? So, but then remember current, I need to update it. So I need to update current. So current needs to be updated. The current address needs to be updated to point to the next node. So current is equals to current next, right, to move to the next node. So I'm getting the next node and then I'm storing it within this current node. There's the current address. But before I move or I shift, right, so this allows me to move to the next node. Before I move and shift and to output the value, right? So what I'm going to do is I'm going to say standard C out. Then I'm going to output the node, right? So I won't actually output any labels. I just output the node. So that means current value dot value. And then I'm going to output an arrow like this to just show that they are linked, right? That's all I'm going to do there, to just show they are linked. And then this will keep traversing until I've reached the last node. So I'm going to output here standard C out and say this is before inserting N7, right? And then I'm going to add an end of line character. So this will be before I insert N7. This is how the linked list, the doubly linked list looks. So I'm going to open my terminal and then I'm just going to test if G++ is installed. I did install it. It should show. So there's the compiler. The compiler is there. And then I'm going to clear and then I'm going to compile what file linked.cpp and then -o. I wanted to create its own object file with its own name. So it's going to be called linked, right? So this is the -o. So redirect it into a file called linked. And then I'm going to press enter. It compiled. You see there's no issues, right? And then ls, I should have in linked. If the file name is highlighted in green in Linux, it means that it's an executable. So I can say /linked like this to execute it. And then I run. Okay, so we have an issue. We have an issue. We have errors, right? We have a segmentation fault. So I'm gonna clear and then I'm gonna see where it went wrong. So while is not equals to now pointer, then move to the next. So let me see. Oh, I think I think I understand what's the issue. So let me minimize this. Right. But it shouldn't really matter. It shouldn't really matter, but it's fine. So this is not, you see this head, right? It's not initialized. Let me see. All of them actually not initialized. Yeah. So what we need to do is I need to remember you cannot use a point unless it's pointing to something. All I'm doing, you see, all I've been doing, right? I've been using, which is very wrong. I've been using the nodes without allocating memory for them, right? So let's do that. So that basically head, you see the head, if you just use head on its own, it's a pointer, right? It's not pointing to anything. So obviously it's gonna throw a segmentation fault because you tried to allocate memory that doesn't exist. So I'm gonna say new node of string type. But then remember, we need to deallocate if we've allocated, right? We need to, at the end of the day, we need to delete memory here. So we're gonna need to do that. So I'm going to do this. So that means N1 and N2, all of them, they need to be initialized. So I'm going to do this. So new N1 instantiate, N2 instantiate, N3 instantiate, N4 instantiate. And then we also need to deallocate, remember. For now, it's very dangerous not to deallocate. So I will just deallocate ASAP. And then N7, is equals to new. So I've allocated, right? So the nodes actually pointing to some address on the heap memory because I've used the new keyword. You could actually make it's gonna become very complicated. That's the problem. There's this thing called unique pointers, smart pointers, right? You could use smart pointers, which deallocate memory manually. You could do that, right? But then I don't want to confuse you guys because this will look very complex. So I'm not going to introduce smart pointers yet, but you can go Google it. Smart pointers are quite useful. So now I need to deallocate memory, right? So I need to delete the memory first. So I'm going to delete head memory N1. Remember, you can put it in multiple lines. In one line, if you're going to use the same thing. Let me see if is it possible to do this. Let's see if it's possible. Yeah, delete n head n1. It's possible to do that. Yeah, but then I'm gonna put it in separate lines. It's fine. Delete n1, delete n2, delete n3, delete n4, delete n5, and then delete n6, and then delete n7. But then don't forget all of them need to be set to null. Is equals to null pointer, n1 is equals to null pointer, n2 is equals to null pointer, and then n3 is equals to null pointer, and then n4 is equals to null pointer, n5 is equals to null pointer, and then n6 is equals to null pointer, and 7 is equals to null pointer. So we've deallocated the memory, so that's fine. It should at least work now. So let's see. Yeah, I don't know why I didn't allocate. I was supposed to make it point to something. Yeah, but for current is fine, right? Because we actually initializing it to heads next, so we don't have to use the new keyword on it or to allocate it on the heap. So I'm gonna press the up arrow to rerun the previous commands. So I need to compile it again and then execute again. So there we go. Now it's fine. But I forgot to what is I forgot to do something here. I forgot to output an end of line character after I'm done. So I need to come here. So as you can see, the node's actually outputting. Now it's working. So standard C out and end of line, a new line character, right? And then I need to compile again and then link again. So there's the linked list. So you see N1 points goes to N2, N3, N4, N5, N6. They're all linked, right? Everything is fine. So now we can actually answer that question. I'm doing this so that when you guys run it, you can actually see output. That's why I took my time. So now let's answer question 2.4, 2.5, I mean. So 2.5, code for containing code for inserting a containing value n7 at the end of the node. So they want you to insert it at the end of the node. You see that it actually helps a lot for you to have a head and tail, whereby you know which one is the head, which one is the tail, which one is the at the front, which one is at the end. Because I don't know what node is at the end. So that means I have to do a whole while loop to go through this node. And the while loop would be for you guys, right? I know you see that it's 5 marks. You'll be like, well, I know it's N6. I can just insert. Well, that's not how it works. You need to actually find the last node, right? So how do you find the last node? So, like I said, there's two ways you can go about doing it, but since okay, the way I'd advise you answer the questions, right? Even though the head and tail are very important. In the diagram, if they did give you, you can use them. If they didn't, you can decide not to use them. It's up to you. But in this case, they didn't show us any head or tail. So that means we actually need to find what's the last node. Just because you can see it doesn't mean it's always going to be the case. Like I said, someone can keep inserting at the end. And then by the time they tell you to insert N7, it's the last node is no longer N6. So how will you know? So that means you have to go through the whole while loop. And then you need to find the value before null. How do you find the value before null? So you need to check that current node's next. And then if that current node's next is pointing to null, then you know you found the last node. Because you see N6 next is pointing to null. So that makes N6 the last node. So that's the main important thing that I need to find, the last node. So I'm going to reuse current. Remember current that we created there. So I'm going to close the terminal. So remember current, we already declared it. So I'm going to reuse current. So this is 2.5, right? So I'm going to say question 2.5, insert N7 at the end, right? It's not sufficient to just give you answers, because when you go there, you won't understand the whole process. So that's why I build the whole linked list, then I try to make the changes. So insert is gonna always start at the head, right? So heads next is where the first node is stored. So I'm gonna start there. Why am I doing that? Because remember, when we exit this while loop, current is actually storing null pointer. It's actually pointing to null. So that's why I have to redo it here to reinitialize it to start at the beginning again. So every time if I'm traversing or going through the linked list, I have to reinitialize it to the first node, because it will be pointing null pointer at that time. So I have this, and then now I need to go through my node. So while current is not equals to null pointer, then what should happen? Remember, we need to obviously move to the next node. So current should be set to the next node. But then, like I said, what's the formula to find the last node? The last node, as you can see in the diagram, its next is pointing to null pointer. That's how we know that's the last node. I don't care about its previous, because its previous doesn't really matter, because all other nodes have a previous, right? So, and if I try to use previous, it's a problem. Why? Because if you check N1, it doesn't have a previous. So my code, before it even begins, it will crash, because previous here is not initialized. It's nothing. So it will crash. So let's not do that. So its next node, maybe this diagram of people would make much more sense. Look at N6, it's next. It's pointing to a null, right? So I need to find that node. So that means the current, because remember what I talked about. Remember what we talked about. In order to traverse or go through the linked list, we create a temporary node called current, and then it starts at the first node, which is the head, but head points to N1, so it actually started N1, then go to N2, then go to N3, then go to N4, and so forth and so forth, right? Until it reaches N6, right? So that means current is at some point will point to N6. So that means I can say currents next, because current at some point will point to that node. Currents next, if it's equals to null pointer, if currents next is equals to null point, way before I even move my arrow here to point to null, way before I do that, here, if it's if current next is pointing to null, then I know that current is currently storing the last node, no pun intended. So if current next is pointing to null pointer, then it means that current is currently storing the last node. Then I can exit my while loop, so that I exit at that point in time, because I know that point at that exact point in time, I'm storing the last node. So I'll demonstrate that it did work by outputting the last node. So let me show you. So I'm going to say if, do an if statement. If current next, right, um, is if current next is actually equal to now pointer, then I know I found the node. So I found the last node, right? Since I found the last node, at that point in time, before I even move to the last node, to now pointer, because if I allow this to go execute, current will actually store now. That's not what I want. So I need to break because I found the node that I'm looking for, which is the last node. To verify this, I'm going to output that I found the last node. So I'm going to say last node, and then I'm going to output its value. So I'm going to say current value, right? And then an end of line character to verify, to show you that it, so I'm expecting it to output N6 because that's the last node. So let's test it out. So I'm going to expand this to make it okay. It's, remember, if you execute or run the previous executable, it's still the previous code. So I need to compile it again, then I can run the executable. So there we go, which is true. You see, the last node is N6. So we found the last node. So now, since we found the last node, we can change the pointers, right? We can change the links. So I did indeed found the last node. So I'm just going to leave that there so that when you look at the CPP file, we can just see the output. So since I found the last node, it's stored inside current, right? So now I need to do my update, right? I need to insert N7. So in terms of the diagram, that means that I need to come here, right? And then I need to insert this to be after N6. So how do I insert it? I start by changing N6 next, right? Remember, N6 was actually pointed to now. So we need to update it to now point to current, because N6 is no longer the last node. So let's do that one step at a time. You see what the first step that I'm doing? It's I'm changing N6 next to point to current. So basically, this is what I'm trying to do. I'm trying to insert it here. So that means I need to change N6. Okay, this is not how I was doing it. So I need to put this here. So I need to change N6 next to point to N7, right? Which is that new node. Remember, we did create N7 node right at the top, even though we didn't use it. There's N7. So its memory is allocated. So that's fine. So I need to set N6 next to point to N7 because now we are trying to insert N7, right? But then in the actual inserting, okay, yeah, okay, it's fine. This whole code is still inserting, all of it is still inserting, so it's fine, except for this output here. And then now N6 next is pointing to N7. That's fine. Okay, this is N7, remember, N7. But then N7's previous needs to point to N6. So I need to do that. N7's previous needs to point to N6. So N7's previous, not N6. What am I doing? My bad. Remember, we used current to find the last node. So I'm gonna say current next point to N7, right? And then N7's previous points to current. But then remember, current actually stores N6, but we had to find it because you never know what the last node is. You can't know exactly what the last node is. You have to find it. So current next, which is basically N6, right? Basically, I'm saying N6 next is equals to N7. And then N7's previous is equals to current, which is N6. So that's basically what I'm doing. But then remember, we use current because we had to find the node, the last node, and then we store that last node inside current. So we're actually accessing the last node via the current variable. Then n7's next. Now it needs to be set to null pointer, so that makes the n7 node the last node since we're inserting it at the end. So I need to say n7's next points to null pointer. So now that makes n7 the last node. Then now we can go through the loop and output. So I'm just going to copy this code again. I need to output after inserting, right? So that you can see. So after inserting n7. But then before I do that, I need to change my current back to point to the head, so that it starts at the beginning, right? But then after here, at this point in time, this is the end of inserting, right? Then here, I'm just outputting changes after inserting N7. So that's what I'm doing. I want to see the output after inserting N7. So let's see the output. So I'm going to open my terminal, press the up arrow to rerun the previous commands, and then I'm going to execute. And then it did insert. I just made a simple mistake. I forgot to set the value for ends for the node. How silly of me. I forgot to set the value. So the value, you can set it at whatever point in time you want to set it. I'll just set it here. N7's value. But typically what I advise you to do is to set it before everything else. So I'm going to say N7's value is equals to the string N7, so that we can actually see the output. So there we go. There's N7. This arrow, this last arrow, it's good, right? Yeah, it's fine. Let's leave that last arrow. Since there's nothing after the last arrow, it will just denote that it's pointing to null. So N7 points to null. So you see, we did insert it perfectly at the right position after the last node, because that's what the question said, at the end of the list. And then provide code for removing the data structure for the node containing a specified value. So they want you to provide code to delete a specific node. So the node that I would decide to delete, right? I'll say let's delete N3. So they want you to delete a node with a specific value. So I will just do this. So there's quite a lot of code here, a lot of coding. So 2.6 code to delete a node with a specific value, right? And okay, I think this is quite a long, this is going to be quite a long recording, but then it's fine. So to delete a specific node with a specific value, how do we do that? So we do that by let me see. So we do that by basically doing the same thing that we did. Remember when you try to find the last node, that code that we have here. But then instead of checking this, we're going to check the value, the current node's value. If it's equals to the value that we're looking for, then we exit. After I've exited, then we can delete. So this is how we're going to do it. This question is actually a bit challenging, but bear with me. Try to bear with me. So we're trying to delete the N3 node, right? This node over here, N3. So we need to create current again, right? So I need to set current to point to the heads next, which heads next point to the first node. And then while current is not pointing to null pointer, that means I'm not at the end. So therefore I can continue, but then I need to update my current to move to the next node. So current is equals to next, right? And then let's check. So how do we find the value we're looking for? So in my case, I'm just going to say, assume we want to delete n3, right? So I'm going to create a string. Um, I'm going to call it strn3, right? And then the string will be n3. Or you can decide not to say n3, that's fine. But then you see the problem with this question, right? You need to understand strings. There's there's methods in strings, right? So before we do this, let's let's touch on strings a bit, because strings, they don't work the way you think they do. Remember with variables, let's say you have num, you actually used to say if num is equals to the 2, something like this. With strings, you can't say equals to. You can't. You have to call a method. So that's why I'm saying this question was actually difficult if you don't know C++ like that. C++ takes years to fully master. And you might not, you actually never master C++. Even the creator of the language, Professor Björn Strostrup, he even said that, yeah, C++ can't master everything. There's a lot in C++. So don't feel bad about not knowing certain things. It's fine. So let's say I have two strings, right? And then str n2, something like this, right? So let's say n2 to compare, right? That's why I'm listen to the terminology that I'm using. I'm saying to compare, to check if these strings are the same. We call a compare method. So it's strn3 dot compare, right? Which expects you to pass another string. So what's the other string? strn2, right? And then this method, it returns an integer, right? The thing is, I haven't used it extensively, this method. I'm assuming since it returns an integer, it's actually the same as in Java, right? Meaning that it returns a one if the if the if the what if the string on if the string on the left hand side is greater than the string on the right hand side, and then it returns or just know it returns not necessarily one but a positive value, right? But then sometimes it can return a one, but then it usually returns a positive value. So before we compare, let me output that. Let me output it, right, so that we can see what the function compare returns. So since these strings are not equal, they are not equal, so it has to either return a positive value or negative value. Positive meaning that the value one string is greater than the other. Negative value meaning that one string is less than the other string. In this case, it returns one. It does actually, it's fine, right? Me, I know that it returns one, but then some people argue that it returns positive. You should say positive. Me, I know exactly what it returns. So why is it saying one? Why is it saying this? So when you see when you do this, right, str3, the string that will be on the left hand side is the string that calls the function, which is str3. So it's going to check under the hood and check if str3 is equals to str2. And what are the values within str3 and str2? Str2 is like str3 is actually was n3, right? And then strn2 was n2. So it checks character by character. It looks at n. Oh, n and n are equal, so I can't do anything there. What about 3? Oh, 3 is greater than 2. So therefore, str3 string is actually greater than this string. That's why it outputted a positive value or 1. Then when you get a -1, it means that the string on the left hand side is less than the string on the right hand side. In this case, I did it on purpose. I changed str3 to be n2 and then strn2 to be n3. So that means 2 will be now less than 3, which means that this will return a -1. So I'm gonna output this. So as you can see, there's the -1 there. So there's no caps in my wraps. So I didn't lie. So as you can see for yourself, so negative value. So for those who'd like to skip the video, yeah, you're gonna fail if they bring this question again, and it'll be all your fault. You should look in the mirror if you're looking for someone to blame. So the string on the left hand side is less than the string on the right hand side. So what happens when they're actually equal? So when they're equal, it returns 0. When they're equal, string on the left hand side is equal to string on the right hand side, right? When the strings are equal, so I'm going to do it on purpose and change this to n3 n3, right? And then I'm going to do this. So you see it returns 0 when they're equal. So that's the string, that's the compare method for strings. There's many other methods. For example, sub string, sub str, which creates a substring, like a smaller string from a bigger string. You don't need to know that. There's okay, you can append to the string. You can convert the string to a C string, meaning a C style string. You can use iterators. That's advanced. That's final year. And then you can also clear the string. You can make a copy of the string, and then you can check if the string is empty. You can erase the string. You can find a specific character by calling find method. There's quite a lot. And then front returns the character in the front. So there's many methods, but the main method we were looking for is the compare, because we want to compare if that value we're looking for is actually, we found the value, so they need to be equal. So what I'm going to do is I'm going to say str value to find. You don't have to do this, right? You can literally pass in the string. You can literally type n3, but I'm using a I'm storing it as a variable. So like I said, whenever we're iterating, I need to keep changing current to be equals to the head, because current will be storing other addresses that we do not want. So while current is not equals to null pointer, right? Current is not equals to null. For those who are skipping the video, this compare method is also inside Java. That's second year comp sci. So if you fail to master it now, you're gonna have problems next year. So master it now. So current, and then I need to update my current address to point to the next node, so that it keeps moving or iterating through the linked list. So now how do we see that we node to look for? So I can do this. I can say str node to look, right? Meaning the node we are looking for. So str node to look. Remember, I need to compare. That's why I was teaching you the compare method inside the string class. So how do I see that I found the node? It's simple. If the current node, remember the current node is stored inside the current variable. If the current node's value, right, its value, but remember its value, you see that its value returns a what? A string. So I can call a compare method after this. So I can say dot compare, right? Because I want to compare this string with another string. What string is that? It's str node to look for, or node to look. So I want, remember, this, because remember this actually returns a string. If this is confusing you, right, you can do this. Remember when you call value returns a string, so you can say string and then you can say current string. Yeah, just call it as current string is equals to value like this, because it sometimes gets confusing. I understand. So I'm gonna say current string like this. So now you can see this is a string that's being compared to another string. So when do I want when do I want to exit? I want to exit when the compare function returns when they are equal. Because remember, when I found the node, that it's when they are equal. So when are they equal? When the function returns 0. So when this is equals to 0, then I found the node. So here I found the node to delete, right? So I found the node to delete, then I can exit. Why am I exiting now? Because this current variable will still be storing that node that I want to delete, and that's very important. So I'll just use the break statement to break out of this while loop, because I found the node that I want to delete based on the value. So yeah, this question was not easy. You better go practice, because this is paper B. They usually choose paper B for main exam. I can, without a doubt, 80% chance of them choosing paper B. Basically, there's an 80% chance of it being exactly the same as this paper in terms of difficulty and question, and asking the exact same way. They might change this to other strings like H1, H2, H3, just a small variation. So if you had studied, you're gonna get 100. But if you chose not to study, that's on you. Some students are gonna get 100 for this exam and get a top achiever award. That's life. If you don't study, some people are going to study. So removing the data structure containing the specified value. So we call the compare method using the specific value. So therefore, now this current variable, it stores the actual node that I want to delete, which is N3. So basically, this is what it means. It means that current, um, okay, current. So remember, this will be current, right? I just choose random, but you can choose N4, whatever, any node. But then always choose a node in between, because that makes it easier for you to master this thing. So this will be current. So after exiting that while loop, current is now pointing to the node that I'm looking for, which is N3, right? It's going to be N3. So I'm currently pointing to N3. Yeah, so this is the diagram. I'll export this diagram for you guys to see. So I'm going to say export as a PNG and then export, and then I'm gonna remove the draw IO name, and then to this device, and then let's open it. So there's the diagram. So that's cool. So there's the current node. So the question is, how do I change, right? How do I delete this node? That's a very important question. How do you delete that node? To delete the node is simple. You change its previous node to point to the node in front of it, basically to skip it. Remember, it's currently pointing here. You want to skip it and point here to this node, right? So you want to skip this node. So that means N2's next should point to the node in front. But we have an issue here. I don't know what node is behind this. This is where serious critical thinking skills are required. Remember, N3, each node stores the previous node and the next node. So if I have N3, I can easily find the previous node by using previous. So I can find its previous node, which is this, by calling previous. So let me do that. So let me now delete the node. So basically I need to find previous. I'll do it. But then that previous node, I need to store it inside its own variable. to make things easier for myself. Trust me, this is way easier. So I'm going to say previous node. It's equals to what node? How do I find it? So current, remember current points to N3, the node that we're looking for. I chose to make it to use current because the node can change. What if they say we are looking for N4? So you see the node now changes. So that's why we use current. So I need to go to current's previous node. Then I get the previous node, which is the node behind N3, which is node N2. Right, so I have access to node N2. But then I also need access to the node in front of N3, which is N4, right? So I'll just say next node. I'll just call it next node. So node, and then standard namespace, the string of type name T, or the string of pointer, and then next node is equals to current. The current node, which is N3, is next. And that's true because look at N3 is next. It actually gives us the address of N4, which is the node in front. So N3 is next. So there we go. Boom. We have access to the nodes now. So now we can change the links. So how do we change the links? So obviously, you'd have to set N3's previous to null and N3's next to null. But before we did that, we needed to keep track of we needed to not lose the addresses, right? So there's many ways you can go about changing it. You can start by setting previous current and the current node you want to delete its previous, set it to null, and then its next, set it to null, so that we cut the link. So you can choose to do that, or you can choose to do this first. I set N2's next to no longer point to N3, but to point to the node in front of it, which is N4 or next node, right? So I'm going to use previous nodes, next, right, to point to the node in front of current, which is next node. So this will be next node. I didn't have to do this, right? You could have just copied current next and then put it here, but then you need a deeper level of understanding to be able to do that. I'm doing it this way to make it easier for you guys. So this would be node N4 so that you guys can actually see it. So this would be node N2. So now what I did is I set N2 to point to the next node, which is the node after N3, which is node N4. So therefore, N2's next now points to N4. So this is what it means. So I'm going to delete this. N2's next, it now points to N4. Okay, so let me do it this way then. Let me do it on top like this. Yeah. So N2's next now points to N4, right? N2's next now points to N4. But then N4's previous, remember this part, after N4, we don't care. It needs to remain the same. That's not our concern. N4's previous is still pointing to N2, N3, which is the current node we want to delete. So we have a problem there. So I need to change N4's previous to no longer point to this, to point to the node behind N3, which is the person behind him, which is N2. So that means N4's previous. And what did we call N4? We called it next node. So that means next nodes previous, right, needs to point to the node before N3, which is this previous node. So it needs to point to previous node. So this is what happens programmatically in terms of code. This is what happened. So this its previous, it now pointed to this node's N2's next. So now you see that there's this guy over here. He's in the middle. So we need to make sure this is deleted. The node's next is deleted, and the node's previous is also deleted. So we need to do two things for each address, for previous and for next. We need to delete the memory first, then set it to now. Then delete the memory for here, then set it to now. Then you'll see that this will now just disappear. So I'm gonna do that. So I need to say current previous. Now we can safely delete, right? So I need to delete current previous. So delete current previous, right? So that it deletes that memory. And then I set current previous to now. So now pointer. And then I also delete current next. Okay, I'm deleting current next, but then also set current next to now so that we safely delete that memory. So now we've safely deleted that memory, right? So if I go back to my diagram, by deleting, this is what happens. We deleted this, so the memory no longer existed. But then we made it point to null, which is just 0. Or in simpler terms, the lines just disappeared. So you see that this one is no longer a part of this system. So it totally disappeared. So that's pretty much how it's going to work. So that's how you delete the node for that specific containing that specified value. So yeah, this was quite a lot of work, a lot of critical thinking. So we could test, right? You might have doubt that, yeah, did it actually delete? I doubt it. Are you sure? So let's traverse through the list to check if it deleted. So traverse through the linked list to see if N3 was deleted. So remember, I need to set my current to point to this first node, which is heads next, then I traverse. So while my current node is not pointing to now pointer, that means I'm not at the end yet. But then in order to eventually get to the end, I need to keep updating current to point to move to the next node. Then remember, we need to output. I could have just copied and pasted, but then it's fine. I'll just type everything. So output the value, the current node's value, and put an arrow there. Then that's it. And then here I need to not forget to output an end of line character. Right? I should not forget to put that end of line character. So I need to also output a comment so that you can see what this output is for. So after deleting N3. Yeah, linked list, if you don't do diagrams, I'm telling you, it's not going to end well. So I advise you doing diagrams. So we have an issue here, segmentation fault. Segmentation fault. Let me see. Did I? So the segmentation fault can only occur if you didn't deallocate pointers well. So that means something I didn't do something right here. So let me see. Let's go back here. So this will obviously store the current node that I'm looking for when it finds it. So I'm definitely sure I found the node. So the issue is here. So let me not delete this, right? So let me not delete that. Let me not delete the memory. Let me not do that. But then it should actually be working. Okay, so it doesn't want you to delete the memory. But yeah, you can see, I don't know if there's, okay, I don't know how to zoom on Linux. But you see after deleting N3, you see that N3 is no longer there, right? N3 is not there. So to don't actually delete, it doesn't want you to delete. You can just set them to now pointer. That's it. That's enough. That's sufficient. So just set them to now, and then that should be sufficient. So as you can see, N3 was actually deleted. I think I should, okay, there was a network issue. I think I should just rename this folder, but then it's fine. I'll rename after I'm done. So I have that file. So I need to, for the next question, for the other questions, I need to have other files, but then it's fine. So let's go to the next question. So there's quite a lot in this question paper. That's why I tend to not finish the question papers because there's quite a lot involved. For example, linked list, it's a topic that you really need to understand. So write the necessary C++ code for the following statements and answer the remaining questions. Unless otherwise indicated, you may assume the necessary header files are included. So they say just assume everything is included, don't overthink it. Basically, they're telling you don't overthink. Most of the marks in this section are awarded for file handling operations, right? They are awarded for file handling operations. So let's do this. So the text file. So this is question 3. So I think I can now safely go back to Notepad++. So this is 3.1, right? So let's see file handling. So the text file immune network.txt is made up of lines in the following format. So you have a B cell ID, B cell. Remember, this is the question that we solved at the top. Yeah, it's that same question, that UML question, this BSL. SL stimulation level. So we still have this. It's like a related thing. It's a continuous thing, like continuous application. So it's made up of the lines in the following format: BSL ID, BSL this, and then N0, and then up to NN. So this means it's a list of neighbors. No, not really neighbors. It's what those list of doubles that they were talking about. As you can see, a set of real numbers. And then EOL, it just means end of line. That means that's where the line ends. It's not part. Don't assume it's part of the line, or it's part of the text. No, it's not part of what you're reading from, what you're outputting from the file. So the data represents an artificial immune network, which is what we did at the top there. Each line represents information of a single B cell. Each B cell has an arbitrary number of neighborhood connections. Each neighborhood connection is a real number representing the connection weight. Each value in a line is separated by a space character, right? So they're all separated by a space. That's important because when it comes to reading, then you'll understand. So by arbitrary number of neighborhood connections, what do they mean by that? Arbitrary, they mean that it differs, right? You might, first line might have 6 neighborhood connections, the next line might have 10, the other one might have 20. So there's no exact number. That's what they mean. So remember when you talked about when you don't actually know the exact number of how many things are in the array, we use a vector or a list. So they're just giving you that hint that, listen, you need to use a vector here. So we're going to use a vector. So each neighborhood connection is a real number, which is a double or a float. Each value in a line is separated by space, right? So the integer of B cell stimulation level, which is a real number. And then this set of real numbers, it's a set, right? Meaning that it's a collection of real numbers, right? If you think about it mathematically, it's a set, right? So it's actually applicable in this scenario. Write code which reads the values from the file and outputs the minimum connection and outputs the minimum connection of each B cell along the minimum connection way of each B cell along with the name of the B cell. What do they mean along with the name of the B cell? That's where they threw me off. How can you output the name of the B cell? Because the B cell only has an ID. I guess they mean the ID. Yeah, that's the only thing that you can output is the ID. Mm. All right, guys. Mm. It's going down here. Don't want to lie to you guys. It's going down in this question paper. I, I, yeah, it was going down. Don't want to lie with you. This was going down. I can think of the code, but I'm thinking in terms of you guys. Will you be ready intellectually to attempt these questions? But yeah, 2023, it was going down. Yeah, it was. Whether you wrote the SIG test or the main, you still suffered. I don't know which one was the main. Maybe paper A was the main, but usually they choose paper B for the main. And then paper A is usually the special. Paper C is the SIG or the SIG, yeah, the SIG or the supplementary. Yeah, I think it's SIG. Yeah, paper C is SIG, and then supplementary it can be paper A or yeah, it has to be paper A supplementary. And then special, it's an I'm sure they have another paper for it. So the integer ID. So I'm assuming the integer ID. Remember, that's what's unique for that neighborhood. I think they made an error here because when we read from the file, right, you see that there's no name for the B cell, but then there is something that uniquely identifies the B cell, which is the ID, sort of like your ID number. So I would rather output that instead of outputting the name because the name is non-existent. There's no name here. So that's why I say this question paper was challenging because there's a lot of things that mistakes and things like that that you'd have to actually ask your lecturer in class during the exam. Raise your hand and then ask a question. Then they'll guide you and help you with where you could be going wrong. So let's see. I could make it simpler, right? I could, instead of writing it inside Notepad, I could just write it inside the C++ file. I think I'll just do that, right? I'll just create a C++ file. Even though it's not gonna run, doesn't matter, but at least when you see it inside VS Code, you see that it looks proper, right? So at least when you see it inside VS Code, you could just click here and create a new file. I'm not gonna do that. I want to So ls, so these are all the files that are there. So I'm gonna say touch to create another file. So this will be question 3.1. I can't say three, let me say 3.1, right? So just know when you see 3.1, it means 3.1. Since I cannot write point one, it will assume the extension is dot one. There's no such file called dot one. So that's why I'm calling it 3.1. So dot cpp, right? And then clear, and then it's fine. I can just exit, and then I'm gonna close, then minimize that. So I'm gonna include IO. Okay, remember, I don't need a lot of things here, but then okay, I do need IO stream, and I need the F stream or the file stream, right? Because we're dealing with file handling. So F stream, and then my main function int main, right? And then I'm gonna go back here. And then remember, it needs to return 0. I'll just say return exit success, which is just still a 0, but then that's a macro, which is just defined inside C. Remember, C as its own special way of defining constants. This is just a constant with a value of 0. You can hover it to see that it's a 0. So yeah, it's just a fancy way of returning 0. So we have this. So let's see. So we need to know the file name. So we have a file name. It's called immunenetwork.txt, and it's a text file, right? So I'm gonna teach you another way of doing file handling, right? So that I did explain it in another video, but then there's another way of doing file handling. You can actually create just an fstream object, meaning that it's not really specific. like what is it doing? Is it an input file stream or is it an output file stream? You can do that. And then give it a name. I'll just call it file in or f in, right? And then you can just pass in the name like this, or you can use call the open method. That's up to you. Then after here, I'm going to specify the mode. As you can see, right here, to specify the mode, you use the iOS underscore base. You can use iOS, that's fine, the one that you've seen on the slides, but then the documentation of C++, it says iOS base. You see that the iOS base here, meaning that the open mode, in what mode am I opening the file? You see that is not really specified because I use f stream. But then if I use an if stream, meaning an input file stream, if you check the IO base mode again, it should be in read mode. Okay, yeah, creates an input file stream, right? Meaning that it's going to be in. Yeah, you see IO base in is automatically included. So it's remember IO base in, it means that it's in input mode, it's in reading mode. So there's many ways. That's why I say C++ you can never really fully master it. I also just recently found out this. So you can see you can use iOS like this, right? Or you can use iOS base. Then you choose in what mode. There's many modes. There's the append mode, and then at the end it moves the pointer to the end, and then begin and moves the pointer to the beginning of the file. Or you can read it in binary mode or whatever, and then or you can move it to the current you can make it point to the current file where you left, and then I think descending, it could be descending, I mean, I think, and then end from the end. There's many ways, right? You can use in for input and then out for outputting to the file or writing to the file. App, it means for append, to continue where you left off. Remember, when you input into the file or write or output to the file, it automatically deletes everything. We do not want to delete everything. So I want to open this in read mode, which is an in. So I'm going to say standard namespace iOS base in input mode, meaning that I'm reading the file. But then do not forget to close the file. Do not forget to close the file. So, or to close the connection to the file, or else it'll continue using your system resources, meaning your operating system's memory, and it might damage something in your operating system. So make sure you close that connection to the file, because with the file stream we create a connection to the file. So let's see. So we're supposed to read in each line, right? So that means there's multiple lines, right? You see that they said it's made up of lines. You need to follow instructions or read instructions clearly. They say it is made up of lines, meaning there's more than one, but we don't know how many lines are there. So what we can do is we can use the getLine method. So the getLine method, it gets a line and then it stores into a string. So I need to actually include the string header file, right? And then I'm going to create a string here, and then I'm going to call it line, right? I'm going to initialize it to an empty string using this the constructor initializer approach, whereby I'm calling the constructor of the string class to initialize it. So I'm just going to pass in an empty string to say it's empty, right? And then I'm going to use a while loop and say while from the standard namespace I use the getLine method, which gets a line, right, from a specific from a specific stream object, so which is f in, and the second parameter is the string you want to store that line in. You see, it's a basic string. It's just a basic string that you want to store the answer in, which is line. And then when you put it within the while loop condition, right, this get line can return a fail state or a pass state. Fail state meaning that it failed to find the line, right? So that's why I put it in the while loop condition. So Well, if it's true, that means it was able to find the line. Therefore, we've stored the line inside get line, inside the line, the string, the line variable, right? And then we need to have a string stream again, because we need to insert it into the string stream, then extract one thing at a time from the string stream. So like I said, this question paper, to be honest, it's high level, pretty advanced thing. So hash include s stream or string stream, which just stands for string stream. And then I'm gonna say standard namespace string stream, and then ss to create that string stream. And remember what we talked about in the file handling video. You always need to clear the string stream here. But then you don't have to clear it if you declare the string stream within the while loop. It's unnecessary to call the clear method. But I'm doing it in this way because I'm declaring the string stream outside the while loop. So now I'm not done. I need to insert the line into the string stream. So let's insert it. So inserting it is basically like C out, right? So remember the way we use C out. Remember, I usually use C out like this, right? So it's the same thing. So I'm inserting it into the string stream. Then now I can extract one thing at a time. And the same order it was added in is the same order you're going to extract. Look at the order of this file. You start by reading ID, then stimulation level, and then there's neighborhood connections. So therefore, I need to read the ID first, then read this, then read that. And then we're gonna need, since like remember what I said, since we do not have this is going to be quite tricky thing, right? Because they say you need to find the connection with the lowest weight, right? To the okay, or it reads the values from the file and then outputs the minimum connection weight of each B cell. Oh, okay, that's fine. Well, I was thinking it in a more advanced way, but then it's fine. So that means we're gonna store it into a vector, and then within that vector, we iterate through the vector to compare to find the minimum within that vector. Once we found the minimum connection, we output that minimum, which is the minimum weight. That's what they mean. That's what they said it outputs, and then along with the name of that B cell. So the B cell name is not there. I don't know what they were talking about. I don't know what they smoked there, but yeah, there's no there's no name of the B cell. What we can output is the ID, because that's what uniquely identifies the B cell. So let's read, right? Remember what are remember this line stores this thing, right? It stores the string stream has this line, which is the ID stimulation level, and then the neighborhood connection, which represents the weight of each connection. So I need and this is more information about everything. So the ID is an integer, so I need to create an integer. So int ID, right? It's gonna start as 0, and then we're gonna have stimulation level, which is a real number. I'm gonna choose a double for that. So stimulation level, then I'm just gonna say 0.0, and then a set of real numbers. They didn't tell you how many, so you know that it's going to be a vector. So I also need to, there's quite a lot involved here. I need to also include the vector header file. So vector, because I do not know how many are there, so I'm just going to use a vector. So standard namespace, get me a vector of what type. Remember they said real, so it's going to be doubles. And then this will be weights, because they're actually weights, right? If you check, they said each connection weight. So there are weights, like your weight, right? You weigh so many kgs, things like that. So it's just your weight, the weight. So now we can read. Remember, we're reading from the string stream, right? It's stored inside the string stream. So what I'm going to do is I'm going to now extract from the string stream. So remember, in the same order I was adding in the string stream is the same order I'm going to extract. And you can also remember the vector, we need to initialize it. You can do this to initialize, to make it won't have any elements, right? But then this can initialize it to 0, everything in the vector to 0, which is not necessary in this case because it's empty, but then it's fine. You can just do whatever you want to do there with the vector. So stimulation ID, that's the integer ID of the B cell, that's the first thing that I'm reading. And then after that, I'm reading what the stimulation level, right? And then for the weights, right? Remember, since I do not know how many weights are there, I need to create a temporary variable called weight. And then I'm going to initialize it to 0.0. That's the temporary variable, which is weight. I'm going to use that. Why am I doing that? You understand shortly what I mean by that. So we're going to do this. Yeah, so we've read the ID of the B cell, and then we've read the stimulation level of the B cell. Now we need to read this set of real numbers and add them to the vector, right? But then we don't know how many weights are there, so that's why I created a local variable, just a temporary variable, to read each weight at a time, as long as there's a weight available. How do I do that? I use a while loop. If you remember the previous video on file handling, you say while, but then I need to use, okay, yeah, it's in the string stream, right? I'm reading from the string stream. So while wait, right? So why am I doing it this way? It can go into a fail state if there's nothing to read within the string stream. So when that fail state is reached, that means this while loop will exit. But while it returns true, it means that I was able to read a weight from the string stream. After reading that weight, because I'm using a while because there's multiple weights, but I do not know how many weights are there, hence I use the while loop. So that weight that I've read, and it's going to keep rewriting and changing this weight. Hence I need to keep track of the weights. So those weights, I need to push them back or push them into the vector or at the back of the vector by using the pushback method. So push back into the weights vector, right? I push back that weight, that specific weight that I found. If it's there, though, if it's not there, then yeah, okay. Obviously, there'll be some weights. If it's 2, it'll only add 2 to this vector. If it's 3, it'll only add 3 to the vector. And then once you're done reading, right? That's why I say this question paper was not playing around. Once you're done reading, they say output the minimum connection. By minimum connection, they mean the minimum value within the vector. Because remember, this vector stores, it represents the connection weight. So they want you to output the minimum connection weight. How would you find the minimum connection weight? Well, you have to go through all the weights. So I have to do a for loop within this while loop. But then after this while loop, after reading, right? So after reading from the file, then I need to find the minimum connection weight, right? And then, yeah, so I need to find the minimum connection weight. So I need to go to the vector. There's multiple ways you can go through the vector. In my case, right, I do not care about, how do I put it? I do not care about the what is this? The index of the vector. So I'm going to use a for each loop because I do not care about the index because they didn't say which position. If they'd said which position or which actual weight, which one, right? Like at what index, then I would have used that for loop. In my case, I'm going to use a for each loop. So a for each loop, Okay, what's the algorithm for finding a minimum? So the algorithm for finding a minimum is simple. You can imagine you're in a beauty contest, right? Right. Let's say since we're finding the minimum, the beauty contest would mean that we're trying to find the most ugliest person, right? So if you take offense, that means you think you're ugly. That's none of my business. That's a personal issue thing. But yeah, it's a beauty ugly contest, right? Finding the most ugliest person, which is the minimum, right? In this case. So you can imagine you have judges, right? People are going to judge. Obviously, if the first person comes and that's the only imagine that's the only person they've seen, which is this person over here, this person over here. So in that case, that means this person, you can with the judges can assume he's the ugliest or she's the ugliest at that point in time because that's the only candidate we've seen. So that's pretty much how the algorithm works. You start by assuming the very first element in that list is the lowest or is the highest, right? Then once you've assumed that's the highest, then the next candidate comes, you compare the two. Which one is ugly between the two? So I'm just gonna say this is person A, this is person B, and then which one is ugly between person A and person B? Now you have to compare. If it's still person A, then it's fine. The minimum or the maximum is still A. And then you bring in person C again, right? Another candidate, which is person C. Then you compare C with A. If C happens to become the ugliest person, we update our maximum or minimum to C. So that's the algorithm. We start by assuming. So I need to create a double called min weight, right, to store the minimum weight. And then this minimum weight, I'm going to initialize it to some value. What value is that? I need to remember what the algorithm says. You assume the first element is the highest or the lowest. So how do I find the first element in a vector? There's the front method and there's the back method. If I'm not mistaken, I think there's the front method dot front and then dot end. Yeah, it's not back, it's end. So there's the front method. If you check this method, what does it say? It says it returns a read-only constant reference to the data at the first element of the vector. So it returns the first element of the vector. So I get the first element, which is the value at the front. Like I said, this this question paper was not playing around. It wasn't playing around. So you get the value in the front, which is the first element, right? You assume that's the minimum weight. Then now you can go through all of the weights to compare. You can right use a for loop. That's fine. Right? You can use a for loop. It's fine. Like the normal for loop, you say int I, blah, you can. But then in this case, you're not going to use I. That's the thing. So there isn't really a need for that. But since I want to avoid comparing myself, since I want to avoid comparing the front with the front again, so you can't compare yourself with yourself. You can't go into ugly contest, then they compare, then they compare, then they compare you and you. No, that's not how it works. They need to compare you with another candidate because obviously the answer will still be you. So yeah, there's something that you need to understand about vectors. Yeah, like I said, this Persian paper was not playing around, it was chowing. But since I understand quite a lot of things in C++, you see the issues, potential issues that you may have. So I'm going through all the weights. So how do I find the size of the weights? You call the size method. But then it should give you a warning, right? Just that it's not, maybe since I'm not inside code blocks, it's not actually saying anything. You see that this function returns a what? Size t, and I'm using an integer. So you actually need to use size t here, or else you're gonna face issues. So you don't have to understand what size t is, you just need to know that size t. So you need to use size t here, which is just some type for just to accommodate some type. It's way too complicated to explain. I don't want to waste time there. So you need to use size t, or else you get an error, a warning. Why size t? Because the size method, it's going to use unsigned, right? And you are using int here. So what if you started a negative something? That means you eventually you'd compare a negative value with a positive value, which is not possible in programming. So hence you get an error. That's why we use size t to be whatever size, whatever data type this returns, it will match with whatever data type it was. So now we're going through everything. But remember what I said. If you start at 0, that means I'm starting at the front. That means I'll compare myself with myself. We do not want that, right? But before we get there, on the comparison, the issue of comparing with yourself, let's do the check. So I'll check if the minimum weight, which is this weight, it's now less than, right? Or not even less than, let's say greater than, yeah. If that minimum weight, okay, no, let me phrase it this way. If the current weight, how do you find the current weight? You say weights and then you index, right? You say I, then you say less than. If that current weight, which is at I, happens to be less than minimum weight, that means minimum weight is actually not the minimum, because I found a value that's actually that happens to be smaller than minimum weight, right? So therefore I need to update minimum weight to be that current value, because that means that current value is actually smaller than the previously assumed minimum weight, right? But there's many ways you can index into a vector. I prefer using the at method. So at, it's actually self-explanatory. You say weights, right? Your vector's name, then you call the at method, which just means at that index. What is the index? Index I. Get me that value at that index. So I'm just gonna use this approach. It's safer. Why is at method safer? The at method is safer because it checks if that index that you're passing is valid. With the square brackets, it doesn't check. That's the problem. So you might think you're indexing into the right, and you're indexing, your index is correct. You might assume your index is correct, but it's actually incorrect. So you don't want to do that. So there's my for loop. But then remember with the for loop, what I was talking about. If I start at 0, that means I start at the front. So that means I'm going to say the value at the front, compare it to whatever value is inside minimum weight, and minimum weight stores the value at the front. That means I'm comparing myself with myself. Why waste that time? Because these values are equal. So this will 100% fail, because the value, if compare you when you compare 1 and 1, what is the answer? If you say 1 is less than 1, what is the answer? It'll always be false. So therefore, I'm going to skip comparing the first one, because we are using that first one as this the minimum weight is the assumption that that's our first minimum weight. So I'm going to start from index 1 going upwards, and then I compare, and then after all of this code right here, I found my minimum. So now I can output the minimum weight. So I'm going to say output minimum weight followed by the actual weight. So what is the weight? It's stored inside the variable min weight. And then I'm going to output an end of line character. And then I'm also going to output they said you should output the name of the B cell. There's no name of the B cell. You can output the ID. That's what uniquely identifies each B cell. They actually made a mistake there. So I'm going to output the B cell ID, which will store it inside the ID variable. And then I'm going to output ID, and then \n. And then we are done with question 3.1. So yeah, that's why I say this question paper was not a joke at all. And then don't forget to clear the string stream so that it's empty every time you read in a new line. And then that's pretty much all we have to do. So this is our code. So yeah, it's pretty advanced, I know, but yeah, that's all you had to do here. You could have also said this is an if stream, it's fine. But then I was just teaching you that there's a different way. You can actually make it of F stream type, but then here you need to specify that you're reading it in input mode so that they know that you're reading the file, not writing to the file. So that's 3.1, which I've called it 3.1. And then let's do 3.2. You see why I tend to not to take my time, because there's quite a lot of things involved. So let's just do 3.2 and then we'll stop there. Let me see how many hours. Yeah, it's 2 hours 29 minutes. So define the define a structure with alignment padding or packing or padding disabled to represent the data for one B cell. So this one, I'm just gonna put it inside Notepad++. So I'm just gonna say 3.2. I mean, I could just make it C++ program, but then it's not necessary. So let's define the record structure. So you, before you define, I need to say struct followed by what's the name of that record structure. So they say this should represent one B cell. So obviously, it's intuitively I know that I should call it B cell since it represents one B cell. So that's it, B cell, right? And then what information is for is stored for a B cell? It's here, it's right here. Previous question. They want you to use common sense. So we need to store the B cell ID, which it clearly states that it's an integer. So B cell, which is int ID, and then okay, I think I can try. Yeah, I think I can try to do all of these questions, right? And then question 4, I'll do it separately. Okay, question 4, I'll do it separately. It'll be its own video because question 4 is DLLs. They tend to be demanding, but we'll explain because this one is a bit different, right? They want you to do the main. So I need to actually show you how to do that. So I'll just finish question 3, right? Let's finish question 3. So we define a structure with alignment packing or padding disabled. So we declare the integer. Now we declare the stimulation level, which is a real number. Like I said, we use doubles. So I'm going to say double and then stimulation level. And then we're going to have those numbers, right? The neighborhood connections, which is the weights. So I'm just going to call it weights. And then remember what we talked about, it's a vector. We do not know exactly how many numbers are there. So it's going to be a standard vector of doubles because I said real numbers. And then this will be weights. And then, okay, in our case, right, it's not going to be a vector. Why? Because now they told you a number. They said you may assume it's a maximum number of 128 neighbors. That means that it's a fixed size array. So I'm going to say double weight, and then the size is 128. So this would be the actual correct way to declare that record structure. Then to disable alignment padding, you're gonna say hash pragma um, is it, but now I'm forgetting, is it pragma? Yeah, pragma pack, and then push. There's multiple ways you can write it. You can say pragma pack push and then comma 1 to say that make it 1 byte, or you can do it in 2 separate lines. That's up to you. This is the first way. Then the second way would be pragma pack 1, right? And then at the end, you need to release back that memory. And then you say hash pragma pop, right, to disable the alignment padding. This is one way to do it. The other way is to just include it in one line like this, say comma 1. So this will be your answer for 3.2. So let's go to the next line. There's a lot of file handling here. Okay, they're really testing whether you are submitting all your practicals, all those things, whether you're cramming. They're testing a lot here. Assume that the file immune network .dat is a pre-existing binary file of homogeneous records. Homogeneous meaning the same thing, right? Heterogeneous means that they're different. In this case, they are homogeneous, meaning they're the same type. So immune network .dat is a pre-existing binary file. It exists, right? It's a pre-existing, right? Binary file of homogeneous records of the type defined in question 3.2 of this record structure. So you must use that record structure. That's what they mean. So whatever name you've used for that record structure, you must use the exact same name for 3.3, or else you lose marks. Just for not using the exact same name, you lose marks because your code is going to crash. You might even get like 2 marks or 2.5 just for using a different name. Make sure you follow instructions. Write code for a function that returns a record from a specified location index in the file. That returns a record. Remember, what record is that? What data type is that? That's the main question you should ask yourself. If you look at 3.2, they say define a structure for data of one B cell. So whatever name you've used is very important. So I've used B cell as the name here. For 3.3, I'm going to use that name. So the function should return a B cell, right? It should return a B cell and write code for a function for a function that returns a record, right, from a specified location in the file. This is what again? Let me see. From a specified location in the file, and it's a binary file. The thing is, they didn't specify. Let's see. They didn't specify this file whether it's just a normal binary file or it's just a random access file. But in this case, they would have. I think they would have been explicit if it was a random file. So random access file. So I'm just going to assume it's just a normal binary file, right? So for this one, it's fine. I can create a CPP file. So question 33.cpp. So it's fine. I can create a CPP file for this one because there's quite a lot involved. And then we need to use fstream. Remember, when you answer this question, right, they don't care about int main or whatever. They just want to see the function. That's it. So since this one doesn't matter, I don't need int main. What I'm going to do is I'm going to okay, that's the file name. What I'm going to do is I'm going to go back to here and then copy this record structure of mine. Put it here. And then this will be, just remember that this is question 3.2. And then question 3.3 is what I'm going to write below. I'm doing this so that it can pick up this type when I say B cell, so that it can highlight and know, oh, that's a record structure. So I'm going to return a B cell, this function. And this function, they said it should what? Returns a record from a specific file. So since it returns a record, that means it gets a record. So I'm going to call it get record at index and then pass in the index. So it gets a record at that specific index. What is the index? So int index. So that's the index. So That's what I'm going to call it. Or you can just call it get record. It's fine. It doesn't really matter. So it needs to return that record, right, when we find it. So let's see. So let's see. So at the specific index. So what we need to do, right? The index is the way it works, right? This is a sim. I want you to think critical. The way you would apply this to the way you'd use the index. How would you say find this? How would you know that that's the actual index? You would say, let's see, you say one. Okay, you start counting at one, right? You can count it to zero, but then I wouldn't advise counting at zero because it's going to be incorrect if you start counting at zero. So you're gonna create a counter. So int counter, and then set it to. I think you can set it to one, right? No, let's set it to zero. It's fine. Let's set it to zero. So set it to zero. Remember, there's multiple ways you can initialize variables. You can use the constructor like this, or curly braces, or just equal sign. There's multiple ways you can initialize variables. Choose whatever way you feel like testing it out or feel like experimenting. So it returns a record structure. It's that specific location. So I need fstream. I did include. So I need to create an fstream object. So I'm going to say fstream, right? I'm teaching you the more advanced way, but you could make it simple for yourself and just say fstream for, okay, we are reading. So if stream, right? And then file or fin to make it shorter. And then do not forget to close the connection, right? And then you can open the file. There's multiple ways. I'm gonna in this file, in this one, since I've demonstrated in the previous question that there's a different way to do it. In this one, I'll do it in another different way. You can say fin.open. We call the open method to open that file. Then you specify what's the file. So I need to copy the file name and use that exact file name. If the file name don't match, you also lose marks. You need to be very careful. But then I need to open it in binary mode. It is by default open in reading mode, right? So if I do this, yeah, it is by default open in reading mode, so I don't have to worry about that. Then I'm going to say iOS base and then binary, because I want to open it in binary mode, right? Because this is so that it knows that this is a binary file. It contains ones and zeros, right? Which is the language of the computer. So we have that. And that B cell that I'm looking for, I need to return it at some point. So I'm going to create a local variable called B cell and call it cell. And then once I found it, I'm going to store it inside this variable. So now I need to read from the file, right? So how do I read from the file? So let me see. You can use EOF, right? In this case, we can use EOF, if I'm not mistaken. Yeah, we can use EOF. There's a function called EOF inside C++. EOF, as you can see, it does pick it up. EOF just means end of file, which is just an integer number minus one. I know it's weird, but binary files are tricky. You wouldn't know where the file ends unless there's some indicator at the end that indicates that this is a binary file. So the way we do that, the way the people made, the programmers who made operating systems and file handling and all those things, they created in such a way that a minus one at the end denotes that this is the end of the file. And you can use a function called EOF to check if I'm not at the end of the file yet. So I'm going to use that approach. So I'm going to use a while loop and say while fin object dot EOF. If you check this, okay, it doesn't really give a lot of explanations, but it checks it returns a boolean true or false to check if you're at the end of the file. So while I'm at, if I leave it like this, it means that while I'm at the end of the file, which makes no sense. So I need to negate this. Remember, in your logic that in your logic class for mathematics, right? When you guys were not taking it serious, logic is being applied here. I'm using the not operator. This is how you denote the not operator inside C++. Use an exclamation mark to say not at end of file, meaning that while I'm not at the end of the file, keep reading. So how do you read? Remember, we use the read method. Dot read, right, which expects two parameters, right? Um, now it seems like I kind of forgot this thing. Let me think. It needs two things. Yeah, it needs two things. The cell, or that record you that record variable, or that variable of that type record, where you're going to store the record after reading it, right? So in order to store it, remember, it's going to be stored in terms of like characters, right? It's in terms of characters. If you actually open a binary file, it's actually in terms of characters. There's special characters, so it's actually strings like char pointer. So that means I want to convert it from one pointer to another pointer. So I need to convert it to a B cell. But that means B cell has to be a pointer. We actually have to make it a pointer. But let's not get into those details for now. Let's see. So reinterpret cast, right? We use reinterpret cast to cast from one pointer to another. So I'm casting from, so let me see. Let me see now. Now, now I just forgot the syntax. I know about writing. Yeah, okay, yeah, now it makes sense. I'm used to writing. That's why. So with writing, you do it like this, right? Const char pointer, then you pass in the cell by address, right? And then you also pass in the size of that record, right? By, you can say b cell like this, or you can pass in the variable. So you can say dot write, and then has no member write. It has no member write because it's if stream. But if I change this to OF stream like this, then it would know, okay, there's a write method. So usually when we write, we did that. So now we need to read. So let me actually use my understanding. Let me use the documentation, right? So dot read. So it reads, and then okay, it reads, you need to pass in, yeah, the char pointer, which is that string, and then the stream size, which is the size of the record structure. So I want to check exactly what does it return. So it returns an I stream. Oh, so it returns this, which is an so it actually returns an object to the thing that we're looking for, right? Extraction without delimiters. So it expects a char pointer, but we are not reading a char pointer, we're reading a B cell, right? And you need to provide the stream size. So let me just check the documentation. So CPP reference. Yeah, there's, like I said, you can know everything in C++. There's quite a lot. So let me say file. Does it actually specify file handling? Yeah, file input and file output. I do not want C functions. It's showing me C functions. I want, oh, it's okay. I want C++, let's say 17, right? C++ 17. Just give me time. Yeah, for you guys, you have to start. I totally forgot. Yeah, just slipped my mind. So let me say file, CPP reference. Okay, let me check it here. Oh, so let me do this. Let me actually type in the header file name. That will be simpler. So let's see. Yeah, so there's the file stream. Why is it not appearing now? Do, 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 do. Const file path, blah, 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 iOS base. But yeah, as you can see what I've been doing, you see they use iOS base in input mode. That's typically what they use. The iOS, yeah, not really sure about that. But then if you check even the way it is implemented, they use iOS base. So I'm supposed to read here and then it returns an output stream. I think, okay, I think the way it works, right? I'm just gonna assume this is the way it works. We're going to read from the file stream and then we put it here into whatever we're passing. And then yeah. So I think it's actually the same. It's the same as writing. Yeah. So I'm gonna say const char pointer and then pass in the address of cell followed by the size of that record structure. What size is the record structure? The record structure is of size it's of size B cell. We use the size of function. The argument is incompatible with the parameter type. Doesn't want, yeah. So when you're reading, no, when you're writing to the file, you use const char. When you're reading from the file, you use char. So what it's going to do is going to read, and then I'm going to use the reinterpret cast because I want to convert it from one pointer type to another pointer type. So, which is just this B cell. So I need to pass in the address, right? You need to pass in the address of that B cell. So now this is going to read from that B cell. But then we still have an issue here. We still have a problem. They said we should only return the one at that specific index. So we are not done reading the file. So what we need to do is we need to say counter plus plus, right? To count, to keep track of which file have I, which record have I read, at what index is that record, and then after incrementing, there's plenty of places you can do this. You can do it after incrementing or before incrementing. Why am I saying before? Because why would before would be a better option because the user, okay, it wouldn't be a better option, no. So, and they wouldn't pass index 0. Yeah, they wouldn't pass index 0. So, yeah, so I'm just going to assume that the index is going to start at position 1, right? So after incrementing, then I'm going to check if counter is equals to that index that I'm looking for. If it is, then I simply break. Because why am I breaking it? Because I found the B cell at that index. So that's pretty much how they want you to read. So you're still reading the same way you normally read the file, but then this is the extra information. You remember, you usually had one line of code, but then now you're going to have this these few lines of code after that after reading from that file. So yeah, that's pretty much what you have to do in 3.3, right? Then 3.4, so I'm just going to write it inside this one file to save time. 3.4 is a pre-existing binary file for homogeneous records, right? Write code for a function which counts the number of records in the file and then outputs an error message if the number of records is greater than 1,000. So it's basically the same code. So for me not to waste time, they say it counts the number of records. It just counts. It doesn't return. So it's going to be of type void. So it's basically this function again with slight variations, right? We are reading from the file again. So it's this function with slight variations, right? So I'm going to remove this part where we counting the records. We don't need that anymore because this is a different scenario and we don't need a parameter. Then this is question 3.4 and then it doesn't have a return type, right? No return type. And we're reading the exact same file, which is immune network.dat. So this is how we read from the file, right? We've read from the file, done. We've read from the file, but then they said we should count the number of records, right? So it counts the number of records. So every time I read from the file, I increment by 1. So I actually need that counter back. So int counter 0, and then every time after reading, I increment by 1 to say that I've read that file, right? Okay, I'm not done in the previous question. My bad. We're supposed to return the cell. I forgot to return. So you must come here and say return cell because we're supposed to get a cell at a specific index within the file. So remember when we exit at this point of time here, the cell that we're looking for is currently stored inside the cell variable. So hence I just simply return it here. And then void get this counts records, right? So I'll say get record count, right? Which means it gets the count of records, right? How many records are there? So we have this. So yeah, after we've counted the record, if and then it outputs an error message. And it should output an error message when what is the case? Only when or only if the number of records is greater than 1,000. So I need after reading, right? After reading, so I need to do a check. If the number of records, which is counter, happens to be greater than 1,000, then what should happen? Standard error, output an error message greater than 1,000, and then put an end of line character. That's pretty much all you had to do. So this question is actually very similar. There's just slight variations. So yeah, 3.3 and 3.4, because we're just reading from the file, right? And then the last but not least, we have this question. So let me see how many. Okay, it's almost 3 hours. Yeah, let me see. Okay, it's fine. I can continue. It's fine. I'll continue. Okay, this time around, I'll upload the code, right? You should check the description of the video. I'll upload the code will be there, or everything that I've written so far will be uploaded. You just click on that link and then you find everything that I've done so far. So analyze the provided code asymptotically using big O notation. And then they say state any assumptions. So we need to state any assumptions so that the person who's going to mark, they know how to calculate it for themselves so that it matches with your runtime, the runtime that you found. So what is the runtime? It's the amount of time that it takes for the code to run. So for example, if you went outside and you jogged for 30 minutes or 30 seconds, whatever time it is, that will be your runtime, right? The amount of time you took to run. Code also does the same thing. It's like running. I agree when you executing code. If you take out a stopwatch and then you click the run button, the moment you click the run button, you also click the start button for the stopwatch. It's going to count, right, how long the program took to run. So we can do that by checking the algorithm, basically the code, and try to improve it and have a smaller number, because if the smaller the number, the shorter the time the code is going to take to run, right? And we want it to be as short as possible. Why is that the case? Would you want, when you click WhatsApp to open and it takes 30 hours to open, would you want that? Nope. You want to click WhatsApp and it opens instantly, just like that. So that's the run time. That's all we're doing here. So there's a specific way to calculate it, right? So we're going to calculate this just for the sake of time. I'm not going to go into all the different runtimes. No, we'll see them as we go along. And they won't ask you very complicated things. You see that the question that they ask you, it's pretty straightforward. And do not always assume just because you have two for loops, it's O of n squared. That's not always the case. Calculate properly before you do and take any rational decisions. Then you can conclude at the end. Then you can see, oh, is it n squared? Or sometimes it can be O of n, even though there's two for loops. Very possible. So that's why I said do not assume. It's not always the case. So let's see. So you need to assume. We start by assuming. Why are we assuming? We want to tell the person who's looking at our code which operators to focus on, or the ones that we decided to focus on. So you start by saying, this is question 3.5, right? You start by saying, assume the operations, right? And then you list the operations. So what are the operations, right? Or the operators? I'm going to assume equal sign. I'm going to look, basically I'm going to count every time I see an equal sign. I'll count. I'll say, oh, 1, 2, 3. That's all we're doing. I'm listing the things that I'll be counting. That's all the first line of code, that the first line that we're going to write. That's what you're telling the person looking at our code, that assume that these operators, you choose which operators to focus on. So I'm gonna look at the equal sign and the less than sign, and then I'm gonna focus on the member access operator, which is the dot. That's also an operator because it's an operation, right? You're doing something there. So I'm gonna put a space there, and then I'm gonna have plus plus, which is also an operator. Plus plus, yeah, it is an operator. Remember, plus plus is basically the same as plus equals. So we are adding, and we're actually doing two things. We are adding and assigning. So I advise you to do this for your code to be accurate. Plus plus, always change it to plus equals. When in your head, change it to plus equals, but you can just say plus plus here, right? Or you can say plus equals to, it's also fine. I'm just going to use plus equals to because I don't want to forget that these are two operations. Basically, these are two operators being used at once. This is one for adding, two for assigning, which is still this, right? So, but then this is in combination, right? In combination, you could, since it's in combination, right, you could say that it's actually okay. There's okay. Let me show you another a way. Remember, plus equals to is just simply you doing this, right? Plus equals to is just simply the same as plus and an equal sign. So you could just say here plus is its own operator, so that you count them as two things, because plus equals to, which is just plus plus, is actually two operators, a plus symbol and an equal sign. So I'm going to do it this way, which is slightly different. You could also, it's fine. You could count, say, plus plus is one operation or one operator. You could do that. The reason why I'm telling you in this way, in ComSci 3A, you do basically this. the whole time you're checking runtime algorithms. So it's important to understand that. So I'll do that. Remember, plus plus is just plus equals 2. So plus, there's plus again. I've already added the plus, so it's fine. I don't have to take it into account. So after that, yeah, so we have the dot, we have the plus plus, which is just a plus and an equal sign combined together. And then equals, we already have equals to. We need to also take into account star, which is the multiplication. So I need to say star, the watashi wa star, and then end is still an operator, right? I'm comparing, it's an operator. So end. So I'm gonna say end, and then what else is needed? And then that's pretty much it. Yeah, that's all the operators we're gonna focus on. There's no other operator here. Don't look at functions, this round bracket. This is a function call, this is not an operator. Do not confuse that. So we're gonna start with let me see. We're gonna start with okay, I'm not done stating my statement, right? So you're going to say assume the operations are a fair measure of complexity. And then you also say that they take the same amount of time. So assume that the operations are fair, they're a fair measure of complexity, and also assume, I'll just write it in full, assume that they take the same amount of time. By same amount, it means that this takes this is one operation. So basically, when you see an equal sign, we're going to put a 1 to say that this takes one operation. This also takes one operation. This also takes one. This also takes one. This also takes one. That means they have the same, they take the same amount of time to execute. They have the same amount of time. They take the same amount of time to execute, right? Or they have the same amount of execution time, in whatever way you want to phrase it. And then you're going to say let n represent the input size. What is the input size? The input size is the number that you enter to solve the program. So by input size, it means that in this case, what number do we need here? It's get rows and get columns. So n represents rows and columns. So it's the number that we need to count up to, right? Or the number that we use to test the algorithm. In this case, we have a for loop, so we're going to need a number to count up to. So we say let n be the input size or represent the input size. And then you also say let t of n, right? T of n represent, right, the runtime, right? The runtime on input size n, right? You don't have to say on input size n, that's not necessary, but I want you to picture it this way. T stands for time. Time of what? Of n. You're calculating the time where the input is n. And if you look at it, then doesn't this look like a function? T of n, it's a function, right? So we are saying that let T of n, this function of this time function with the input n represent the runtime of our algorithm, right? The runtime of the algorithm on input size n. Then now we can start calculating, right? So we can start calculating the runtime complexity. So how do you start? You always start with the innermost, which is this for loop, which is the inner for loop. So I'll say innermost loop. So let's calculate for the innermost loop. So with the innermost loop, right? In this case, the outermost loop, the innermost loop, right? It executes that specific number of times, right? Let's say it execute 2 times times the number of times the outermost loop executes. So if I have the inner for loop goes 2 times, since it's within the for loop for rows, it'll execute 2 times times the number of rows. So it'll be repeated. So for example, if I have 2 rows and I have 2 columns, those 2 columns will be displayed twice. So if they're displayed twice, that will be 4, right? So that means 2 times 2 is 4. So therefore, the innermost loop will be executed for its own specific number of times times the number of times its outermost loop executes, because it's within that another loop which also runs on its own specific number of times. So that means if every answer I get within the innermost loop, I need to times it by n, which is the outermost loop. So let's do that. So in this example, right, they made things simple for you guys. It actually goes up to n, right? It starts at exactly 0 and it stops right before get calls, which means that it goes up to n, which is the actual input size, which is n. So if n was get calls, it goes through all the get calls. Therefore, each for loop executes n times, right? That's very important to know. So innermost loop, what do we have? We have equals, we have one operator here, right? There's that one operator. So I have that operator. So I'm going to have 1 plus this other one, right? Then this other one. So that's 2. So 1 plus 2. And then what else do we need? Okay, in this if statement, right, we have this operator here. But before we do that, I forgot to, you see the loop condition. I forgot to take into account the loop condition. So let's take that. It's called, so we can say loop condition, right? And then put it in brackets plus the loop body. So I'm going to do it this way, times n, which is the input size, right? But before we get to times n, let's just see what we're going to write. So for the loop condition, right? What is loop condition? It means this part in the condition for the loop. So how many operators do we have? I have equal, which is 1. I have less than, which is 2. I have dot, which is 3, right? And then so I have 3 so far. Remember, plus is 2 operators. Plus is plus and an equal sign, so that's 2. So 3 plus 2, that's 5. So the loop condition would be 5. That's the answer. That those are the number of operators that I have. Why am I saying 5? Because I remember what I assumed. Assume that they take the same amount of time to execute. So that means they're all ones. If you see it, just count 1. Just say add 1, just say 1. So that's why I got 5 here for the loop condition. This is for the innermost loop. And then for the loop body, which is within the loop, that's the loop body. That's what we call the loop body. Within the loop, which is this code here. All of this code here, that's within the loop. But then it's within what loop? Innermost loop. So, which is the columns loop. You can't say columns loop. You need to say innermost loop and outer loop. Those are the two terms you use. So I have that. Now I go within the inner loop. So let's count how many operators are within the inner loop. It's 1, right? 2, 3, 4, that's the plus, 5, 6, 7, 8, 9, 10, 11, right? It's 11. Those are the ones that we agreed upon, right? We said that those are the ones that we said assume that they are they are they they are a fair measure of complexity, right? Those are the operators we said in our assumption. So I'm only going to count those. So I think I said 11, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's 12. Yeah, so we have 12, which are in the innermost, in the loop body, right? So that's 12. But then remember something, don't forget, make sure you don't forget something here. This inner loop goes how many times? N times. So whatever values are found here, I need to times them by n because they get executed n times since they are within the columns loop. So whatever value I got here, and also whatever value I got here, right? The values that I got here, they're executed within the loop. But they're not, you see, this is, you see, now I'm starting to, you see, when you understand code a bit better, you start to think critically. For the loop body, for the loop condition, right? It's not true that all of them are executed n times. Why? Because int c is equals to 0, it gets executed exactly once. And then even this one, int r is equals to row, int r is equals to 0, it's also executed exactly once. So it's not necessarily true. So what I'm going to do, right, for the loop condition, I'm going to say it is 5, right? It is 5. So it is 5. So I'm going to say for the loop condition, it's 4, right? And then plus 1, which is the initialization part, right? And then we look at the ones that I know I know it might not really make sense to you, but I like to to be honest, it don't make any difference. But you need to be accurate, like 100% accurate. Because this line of code, whenever within a loop you say int something is equals to 0, it gets executed exactly once. So to times it by n is incorrect. So this will be executed n times. Also, this will be executed n times. So times n. But then we're still within the inner loop, right? So this will be executed n times. And then this also be executed n times. So that I can times it by n, which is that 4, right? So it'll be times n, right? It'll be times n because it's executed n times since it's within the, remember it's going to be repeated n times, so I have to times it by n. Then for the loop body, it's within the loop, so it will be executed n times, so I times that by n. I times that by n because it will be executed n times since it's within the body. Remember this loop, while loop, it will go back to the top, check if this is true, and then repeat that thing again, go back to the top, check if this is true, and then repeat the thing again until what c is actually equals to get calls. That means this is now false. That means I've gone through all of the columns, right? So that means it will get executed n times. I could take my time and make a separate video to explain it step by step, because this would also take its own time, just like linked lists. But just know if it's within a loop and you start exactly at 0 and you stop at the number before the actual rows or columns, it's n. That means you're going through the whole input size, meaning you're going through the whole columns and the whole rows. So I'm done with the inner loop, right? We're done with that. That's a done deal. Now we go to the outer loop. So we go to the outer loop. So the outer loop, right, it still has a loop condition, remember? We have this loop condition. But then remember, int r is equals to 0 gets executed exactly once, right? So I'm going to copy this, right, like this. Because that loop is, remember the outer loop, it still has a body, which is another loop. So it still actually has a body. So we need to repeat basically what we did on outermost loop. So on outermost loop, we said the loop condition is how many operators it executed. So let's see, let's count the operators, right? So 1, 2, 3, and then remember this is 2. So 3 plus 2 is 5. So it's exactly the same as the previous one. But I can't say 5 times n because that one operator gets executed exactly once. So I need to leave it as a constant n. So this actually matches with the previous loop, right? This loop condition part, it should match with the inner loop. In this case, because they both go through all of the rows and all of the columns, so the answer should match. Then now for the loop body, it's a bit different. So let's look at the loop body. So the loop body, it's how many times this executes times the how many times the outer loop executes. So the inner loop executes n times, right? Because it goes through all of the columns. But then the outer loop also executes n times. So that would be n times n. So the answer here would be n times n. And then we have our answer, right? And therefore now I can calculate, I can say therefore, you don't have to demonstrate this, right? But you could show it, right? You could say T of n is equals to, right? So T of n is equals to, you can now show it, right? You can now say T of n is equals to innermost loop plus outer loop, right? Now just simple math. We're just doing maths here. And then this would be this whole thing plus the whole formula for the outer loop, right? But then that formula, we can break it down. We can omit the upper loop condition, whatever. You can just take the actual answers or the actual values. So 4 times n is just 4n, right? Plus 1 for the initialization, right? And then the loop body is just 12 times n, which is just 12n, plus this again 4n plus 1, 4n plus 1, and then plus the loop body, which is n times n, which is n squared, right? Then we calculate, we add up, we look at like terms, right? 4n time plus 12n, that's 16n, plus 4n, that's 20n. But then let's write it in the right order when you actually write the answers in terms of exponent powers, right? So n squared plus 20n plus 1 plus 1, which is just a 2. So the actual formula is n squared plus 20n plus 2. So now how do we find the runtime? You just look, do you know why we actually conclude by looking at the exponent with the highest power? Because all the other values don't actually change the shape of the graph. So try to draw this graph n squared and then see that if you add 20n and then you also add 2, it's insignificant things, right? It doesn't change anything. So after this, we can say, therefore, T of n has a runtime of order of n squared. So we choose the term with the highest. So basically when you see this formula, right, you should ask yourself, what type of graph is this, right? This is a quadratic graph. It's a quadratic equation, right? So quadratic equation, it's, as you can see, it's ax squared plus bx plus c, right? But then in this case, a is 1, and then x is n, b is 20, x is n, c is 2. So it doesn't actually change the graph. The graph is still in n squared, right? The graph is going to be ax squared, so it doesn't change the graph at all. So that's why we say that therefore T of n has a runtime of order of n squared. So that's pretty much what you had to do there. So yeah, that's it, guys. This would be this answer that I gave you. It's actually the answer that the 100% correct answer that Dr. Stung would give in the memo. But then their main goal is that you get n squared as the final answer. They don't care what values you get because they're insignificant. The only thing that we want to know is the shape of the graph. That's it. So keep that in mind. But then this is exactly how Dr. Stung would approach it. Because if you understand coding, you know that this takes exactly one time, right? It gets executed once, not n times. So thanks for watching. I'll continue with the DLLs. I'll make a separate video for DLLs because now this video is becoming way too long.